To day one of Northeast PHP Talks. I have the distinct pleasure to introduce to you guys the last talk in this room for today, which is a man named Ross Tuck. He's actually from the Netherlands. This guy last year paid his own flight to come and speak at our conference. That's how amazing he is. That's pretty sweet, and I don't think it's very cheap. This year we helped him out a little bit. Yeah, we can clap for that. Let's do it. Woo-hoo! Not only did he pay for his own flight, he also gave an amazing talk, and we're really excited to have him here again this year. I love his hat, and he'd also like me to tell you guys that he's a Virgo, and he likes long walks on short beaches, so if you like pacing, you guys should totally hang out with Ross. Here we go.
I'm actually a Scorpio.
He's lying.
Okay, so yes, thank you for coming. This is my talk, Team Plaatjes, building JS applications with vector graphics. Now, just to give you an idea about what you can expect from this talk today, I know it says vector graphics in the title. It's going to be a little bit less about shiny 3D swordfish hacker cubes and a little bit more about just building applications that happen to use vector graphics. So if that doesn't sound quite like what you signed up for, then I'm going to close my eyes for a little bit, and you guys can just sneak out the back and go see Jonathan Klein's talk. No hard feelings, okay? I'm also going to go pretty quick. So, in case you didn't notice by now, my name is Ross Tuck. I'm on Freenode and Twitter as creatively Ross Tuck. And I happen to, wow, that blew up fast. Okay, anyways, Twitter, Freenode, Ross Tuck. Okay, so I'm a specialist at a company called Ibuildings. And Ibuildings is a PHP consultancy. We also do a couple other little things, but that's kind of our bread and butter. Now, I happen to be an expat. I'm originally from down south in the US, but Ibuildings is in the Netherlands, and I've been there about 5 years or so now. So, up until recently, I worked as part of a division called Team Plaatjes, which is the Dutch word for team pictures. That's, yeah, it's an inside joke. But a little bit about the team real quick here. It was made up out of these guys. The stuff I'm presenting today is based on our experiences together, so I can't really take the credit for this talk. It's these guys in particular. You should follow them on Twitter. They're all great speakers and great engineers in their own right, okay? So, how do we become known as Team Plaatjes, right? What does that even mean? All right, so it happened like this. We were in a meeting with a client, and it was like one of those meetings where they're talking about they want to replace this application they've had for like 10 years. And you know, they name a feature and you just have this great idea about how you're going to implement it. It was a really, really exciting project. So they wanted to do like a particular type of versioning and archiving that was very, very complicated. And they had some searching would be done in a Solr full text index. And then there'd be cool validation and business rules that had to be applied across the board everywhere. And it draws diagrams in the browser. And we were like, wait, what? It does what? They said, yeah, the application. It's for drawing diagrams in the browser. Oh, we're PHP guys. So we're like, huh. How does that work? So I want to be clear that they were talking about diagrams, not a flowchart, because it turns out it's fairly easy to draw a flowchart. You just draw some shapes, you hang them at X, Y coordinates, give them some attributes, and then you save that, okay? But we're talking about a diagram, like a really like complicated business rules diagram where if I change something over here, this entire part has to redraw in a very complicated way. And that turns out to be a lot more complicated than you think. So step one for us was figuring out what's out there, what technologies are available for us in the browser to do this kind of thing. Well, spoiler alert, in case you didn't guess from the title of the talk, we used SVG. But we did actually look at a couple different technologies out there. I mean, Flash is the first thing that came to mind. You know, okay, but the main thing about Flash is that it didn't work on the Citrix environment they had. They were also thinking about targeting mobile, and they'd just gotten done migrating some stuff off Flash. They wanted no more of it, so it was a no-go for our client. We considered WebGL, not right for our use case. CSS didn't have all the features we needed. So the main two we concentrated on were Canvas and SVG. Now, the Canvas is you know, kind of a first good contender here. It's hot, and I don't mean that like it's a trend or a fad or something, but I mean it's got a community, it's got documentation, it's got libraries. I mean, it's a good thing. It's also really, really fast. We're concerned about performance with this application. It is raster-based, which is not necessarily good or bad. It's just, you know, it's raster graphics. That was a little bit of a downside for us, maybe if we had to think about doing mobile. And the browser support is from IE9 and above. All right, so it's good, it's better than you think, but it's not perfect. The downside, the main thing that turned us off as a bunch of PHP guys kind of tossed into this, is that it's relatively complex. If I show you a simple example, my slides are actually done here in a browser. This is two blocks. If I click on one, then it shows me the coordinates I clicked. okay? Now, I got this example from Stack Overflow, and a guy named Matt King wrote this, and this is his sample code to draw that. Okay, here's the equivalent SVG example. Okay, so that was kind of a compelling thing for us. So what is SVG? Well, it's scalable vector graphics. It's designed primarily for working for 2D data. It's good for us. It's pretty simple, and the programming model for it is rather familiar. It's basically DOM manipulation, as you'll see later on. Now, it is vector, not necessarily good or bad, but worked well for our use case. The two main downsides with it are speed. Vector graphics are a little bit more computationally expensive probably, so they're inherently always a little slower, and it is DOM-based, which kind of stacks onto that. But it is, fast enough, TM. The other thing is it's kind of a forgotten technology. It was standardized, almost the better part of a decade ago, but not so much has happened with it. Browser support really lagged behind, and whenever we went looking for documentation about people building SVG applications, then it was all dated like circa 2007. Now there has been a resurgence of interest in SVG in say the last 3 to 5 months, but when we got started with this about 14 months ago, it was like, we called it code archaeology at times. All right, so that's where we ended up. SVG seemed like the best fit for us. So step 2, research. All right, how can we go forward in it? What is SVG exactly? Okay, now to back up a sec here, SVG is XML for pictures. All right, that's how it's implemented. It's a standard format. It's just like a JPEG or a GIF or anything like that. You can actually include it in your browser with an image tag, and it will scale to all sorts of crazy dimensions. Now, the cool thing about SVG is because it's an XML dialect, though, you can actually put it inside your HTML. And I don't mean in some funky XHTML namespace way. I mean, it's just an SVG open tag, SVG closing tag, and some stuff in between. All right? Ain't rocket science. But the cool thing is by doing that, it becomes DOM elements, and then you can program them with JavaScript. So a simple SVG drawing looks like this. I'm just going to create an SVG drawing area. It's got a CX and a CY attribute. That means the center X and Y of a circle I'm drawing. It has a radius of 40, and it's got a fill, and that's the color blue. Ta-da! Okay. So you can go more complicated with this. This is an example with opacity and border radius, and it has a stroke, which is SVG speak for border. Okay. So that's kind of what you can do with it. But the JavaScript manipulation is cool because I could do things like, I don't know, I could change the color red on this into green, for example, with a nice animation. I could animate the radius growing, for example. I could move it that way. I could change several things at once. I could use an easing animation. I could make it move in sync with other things on the screen as it flies away from you, okay? All right. So it's kind of like Flash circa 2001, eh? Now, one of the cool things about SVG is because it just integrates with the HTML, then it's a mix and match technology. I can use this with HTML forms. I don't have to go re-implement a bunch of controls or anything like that. For example, if you see that little fade animation I use between my slides, then that's actually a CSS animation from reveal.js. But it looks nice on all the SVG stuff I draw on the screen too. All right. So I haven't talked about browser support though, which was a big deal for us. All right, now it works on all modern browsers. And no offense to our host here today, but that basically means everything not Internet Explorer up to a certain point. But it is working pretty well from IE9 and further. And by all rights from IE9, it's actually pretty good support. It works on mobile fairly well, and this is all pretty good. It's pretty good. But it wasn't good enough for us. All right, we needed IE8. It was required by our client. And there was even a discussion about whether or not we needed 7. Okay? So we thought, this is good, but how can we do it? I mean, we looked at some polyfills, but okay, these don't quite work out for us. There's reports that they don't work always. Some of them use Flash as a backup. Some of them are abandoned. So we skipped that. Now, that's where VML came in for us. Now, VML is vector markup language, which sounds suspiciously similar to scalable vector graphics. It was a Microsoft standard, and it was actually a predecessor to SVG. It, along with another standard from Adobe called PRML, were submitted to the W3C and formed the foundation for SVG. Okay. Yes. Now, ultimately, from IE9 and above, it was deprecated, and it's there. But it has been in place in Internet Explorer. I thought from version 6, but I was corrected to version 5.5 actually. So you could use this to do that. And if you look at the two dialects, they are surprisingly similar. I mean, SVG talks about circles. This one talks about ovals. This one has attributes. This one is sort of a CSS markup. Potato, potato. If only we had some kind of compatibility layer. So, step 3. This is the logo for a library called Raphael.js. Now, Raphael was written by a guy named Dmitry Bera, I can't pronounce it correctly, Ofsky. He started in 2008, and he's continued on. It's got a pretty good community behind it. The reference docs are not too bad at all. And its primary function is an SVG drawing library. That's what it does. I mean, the SVG markup you've seen so far is not really hard, but Raphael makes it just a little bit easier. Okay? What's unique about Raphael, on the other hand, is that it has a VML fallback. It can detect what kind of drawing engine you have in your browser, and it will adapt to that, and it will normalize the result for you. So using Raphael, you can draw essentially SVG images all the way back to IE 5.5, and they will work pretty much just fine. Now there are some alternatives out there we talked about. I won't talk about all of them, but D3 is really worth looking at if you don't need to support older versions of browsers, and you're really interested in sort of like plotting data on the screen. The learning curve is a little bit steeper. Raphael is more of a plain drawing library. But D3 is really, really cool. And if you do need that backwards compatibility, there's a project talking about merging it with Raphael to some degree, which has a really sweet name, which is R2D3. There's Dojo, I think may also have a VML fallback, but, and I say this as a criticism of us, not Dojo. It's like everything cool in Dojo, nobody really knows it exists. All right, so there's a couple other things, but those are the main ones we looked at. Now, I'm going to show you some examples. This is not a Raphael talk per se, but I am going to use Raphael for the examples. And the idea is to sort of give you an idea of what you can practically do with SVG, all right, in a very simple way. So, now setting up Raphael is simple. You just include a JavaScript file on your page, and then you call the Raphael function here. Now you can do that by either passing in the coordinates you want it to appear at, absolutely on the screen, or by a div, and then the height and width of what you want to draw on. So 640 by 480 in this case. And that will act like a div with a particular size. Things will flow around it, so it actually sort of has mass in your screen. You'll also note that I'm not using a new constructor here. That's because it will work, but Raphael prefers to act as a factory rather than a constructor. Sure.
Is my div like an idea of it?
Yes, it is the idea of a div. Wait. Now, actually drawing is pretty straightforward. All right, all you do is you have a paper variable now, and paper is sort of like the standard name of Raphael's drawing area, and then you can say paper.rect, rectangle, and then at 25 by 25 on the screen, I want a 60 by 80 rectangle. Ta-da! Okay. Now what I can do then is use the attribute function, attr, and I can sort of manipulate the stuff on the screen at one time, fill it with the color like you saw earlier, or I can manipulate multiple things at one time by saying, hey, stroke and stroke width. All right? So, nothing fancy. Now, one of the great things about Raphael is that it has interactive libraries. I can add event handlers to this stuff. So I could draw a circle on the screen, I could fill it with a particular color, and then I could hang a click handler on it. So if I just come over here and I click the circle real quick, you get another fancy alert box. One thing to note is that if you're trying to make something clickable, make sure you put a fill in it, all right? Because otherwise it is essentially empty, and the only way you'll make it clickable is by clicking on a very thin border around it. So make sure you do that, even if it's just a hotspot element, give it a fill, then turn it transparent. Now, one thing to know about events in Raphael. This ain't jQuery. Raphael will normalize browser drawing differences, but it does not use jQuery for its events. It uses its own library called Eve, and Eve will not account for browser differences. You will get all the joyous fun of rediscovering event.target versus event.currentTarget, depending on what your browser is. So the easiest way we found to fix this is to use jQuery, ironically. It has an event.fix function. You can just use that on a native browser event, and then that will just pass back an event. And this fixes a whole host of other problems. For example, there's versions of IE where if you try and pass the event off to another function that you might want to read the coordinates from, like a tooltip library or something, then it will just like disappear out of memory in some cases. Like it'll just disappear. It passes it, and then it's gone. I'm not making it up, man. Don't cross the streams. If you're using Raphael to do event handling, don't use jQuery in the same elements. Use jQuery in order to do like the event.fix function, but don't use it to hang more handlers on there. Otherwise, they'll conflict and you'll get into ugly situations. Okay, a really cool feature of Raphael is sets. Now, sets are like set start and set finish. They sort of open a set, and then it will record everything you draw in there. And this will hand you back a composite element. So if I draw two rectangles in that meantime, I'll get back this my set variable, and then I can use that in order to sort of like change multiple things on everything I've drawn at the same time. So this is really, really handy because then I can also add more stuff to it in the future, like a new rectangle. It does not immediately take the current state. It waits for, say, the next thing that you're going to do, and then it will affect everything at once. There's an alternate syntax that's not using set start and set finish, which is kind of like a static construction almost. But you can say paper.set, that'll give you an empty one, and then you can just do set.push, set.push, set.push in order to add things to it. That's maybe a bit better. Now, something else then you can do is create sets for things that you draw on the screen in one go, because a common pattern when doing this is you want to draw multiple things on the screen and then remove them in one go, so that you can redraw whatever the new updated state is. So if you keep a set of that stuff, then you can just remove it all at once, ta-da, and go forward with your life. It's just a common little thing you see. Okay. Now, this is a feature that's in SVG itself, and it's one of my personal favorites. This is where it starts to get cool. Now, paths are sort of like that little ink tool that you always use and never really quite understand. They let you draw any arbitrary shape you want. So if I wanted to create a triangle, for example, that's not something that's natively supported by SVG. There's circles, there's rectangles, but there's no triangles. So paths give you a way to describe the movements of an imaginary paintbrush on your drawing surface. So they do that by specifying first a letter there, in this case M, and then maybe sometimes some coordinates. So it's like a list of commands of what to do with your paintbrush. So I'm going to start off with M, which means move. All right, and that's going to put my imaginary paintbrush, it's going to pick it up from off screen and put it right here. Now, it's not going to draw anything at that point, it's just hovering over there. It's move to 60 by 60. All right, now I'm going to go into the next command, which is line 2. And it's going to take my paintbrush from its current location and draw a line to the new coordinates at 210 by 60. All right, so it's just going to, and then stop there. And that's where the paintbrush rests again. Now, there's another line 2 command after that, and it will move down to those coordinates. And then it will move over to the Z command. And the Z is just like close. Like move my paintbrush back to the very first place I started at and finish this shape. And now I have a triangle on the screen. All right? Now, the really cool thing about this is that you can begin manipulating these things just like you would anything else you drew. So I could use ATTR fill in this, like you saw in previous examples, and SVG is smart enough to fill like the exact shape I just drew, which I think is kind of cool. Now, you can use this for almost anything you want. I mean, you're not going to get photorealistic stuff out of paths. It's not designed for that. But you can do more complicated shapes, for example. Now, if the idea of like actually typing this in command by command fills you with dread, and it should, then I would actually recommend that you open up Inkscape or Illustrator. You draw the shape you want, and then you save it as an SVG. Now, SVG is just XML. Then you can open it in your text editor, scroll down to the path element, and copy and paste the string out of there and into your code. That will work. I'm not kidding. That's how I got this in here. All right?
Can you say that all over one more time?
I'm sorry, I moved quickly. That's my fault. If you just create the shape you want, like this light bulb in Inkscape or Illustrator or whatever, then you can just save it as SVG. That will just be a text file on your computer. You open it up, look for the path. It's like a piece of the XML. It's literally a path tag. And then it will have that entire string for whatever this shape is in there. And you can just copy and paste it into your code.
I have a question. I've worked fairly extensively with Inkscape, and I've created some like really complex paths.
Yeah.
And they can get pretty lengthy. So what would you suggest that kind of stuff? Suggest just copying it and putting it in there?
Yep. Yeah, just copy paste it. Sometimes it'll be like several thousand characters long, and sometimes it'll actually be composed of multiple paths, and you'll just want to lay them over each other. But that's what works best for me. Sure.
Do you reference it in like an external files with dependencies will use your advantage?
Yeah, we use require.js actually. We don't love it a lot, but it is the best darn thing we found for that. And then you can load in external files as objects.
Oh, nice.
And that works really well. Anything else? I'm just warning you now, this talk is already going to go long, so if you want to bail at any point, feel free. Okay? All right. So the cool thing is, once I've got it on the screen, though, I can like do other tricks with it, like fill or animate or whatever I want. All right. So let's talk about animation. You've seen me do it a couple times now. I need something on the screen to animate, so I'll use a mustache, and then I will just describe what I want as the end properties, just like I would with the attribute function. So in this case, I want it to be a mighty red. I want a mighty red mustache, and then I can just define that point along with the number of seconds it takes, and it will work out all the in-between frames. I'm basically describing a tween if you've ever worked in Flash. All right? So that's all there is to it. Unfortunately, my girlfriend will not let me have a mighty red mustache. I'll turn that back. Now, the cool thing about this is that you can do things you wouldn't normally think of as attributes. So like transformations, like manipulations of the shape, are an attribute in SVG. So you can do transforms. Now, Raphael uses its own little DSL. This is one of the few places it diverges from the SVG spec. Most of the other stuff is all taken from there directly. But it uses, like, just like with the path, you can say R, 180, that's rotate the shape 180 degrees, and then T, translate, which is graphics talk for, well, move. and then this will move it down 100 pixels. All right, so the second example will go, it's pretty smooth actually, looks all right. Now, with great power comes great responsibility, so you might be tempted to, like, you know, animate all the things. Don't, okay? Use this for like small things, like when the user mouses over something, or just wants to make it grow a little bit, or, you know, bring some attention to something, all right? But don't go crazy with it. Now, the last example I want to show you real quick is path animation. This is really cool. All right, so what you can do is you can say a path definition, and that's just going to be something like an arrow. There's this handy arrow in functionality on here. So it just looks like this. That's native in SVG. But I can define a new path, all right? And that's just going to be the same as this other one, but it's going to have an extra line going down at the end of it, okay? Now, I can animate the change from the first path to the second path. Don't think about it too hard. It's easier if you don't think about it too hard, all right? Because then when I run it, it just draws the actual shape I want, and it looks pretty good. I mean, you can really see with an arrow like this about how you might use this to, for example, you know, point to a user, hey, take this route, or click this button, or something like that. You can also use more complicated shapes that you might import from, you know, Inkscape or whatever. So I could, for example, change this germinating seed into a flower, although it can get a little freaky. Yeah. Okay. So that's kind of the basics of what you can do with SVG. There's a lot more to it, and it's still evolving. There's like some crazy filters and stuff you can do, but this is kind of the basic set of things. So now I want to build this into an actual application. I want to build, you know, an application that just happens to use SVG. That's kind of the main thing to keep in mind. Now, the question here is, what should we build? Because I was really looking for an example about what to do this with. I mean, the application we build is this crazy business process modeling chart. It's like these guys are ISO certified for many things, and so they have to follow these flowcharts and document them exactly. They have a flowchart for what to do when you don't follow the flowchart. Really, it's pretty cool. But the question is, what should we build? Now, it has to be something a bit more complex. It must have a more complex data structure because you want to visualize it, not read about it. All right. So I decided to use something common to all of us, DNA. Now, you usually think about DNA as like being like this sort of double helix, okay? But it has a couple business rules that we need to keep in mind. So just a quick 8th grade science refresher, okay? Business rules. DNA is made up of pairs. That's what they're called. They're called pairs because it's a pair of 2 bases. Now, there are different types of bases. They're called G, C, A, and T, and they can only bind in certain ways. G can only go with C, A can only go with T. All right? It doesn't matter what order. It could be C with G, T with A, but that's the general thing. All right? If you can't remember that, then use what I do, the mnemonic GCAT, like a gangster kitty. All right? So, now, the first thing you should think about before you ever start coding is exactly what I'm going to put on the screen. All right? Now, this is not just me explaining the domain model for far too long. This is a really, really important step that you actually need to think about hard in your design phase. What are you going to show? Because if you look at this is pretty cool, but it's not so easy to read. You know, what is this pair right here? I cannot tell for the life of me. I can't tell. It's something in the curve there. All right? So I looked at Wikipedia and I found this diagram. Now, it may not seem like the same thing at first, but if you were to take the DNA and you were to uncurl it and tip it over on its side so that the bases became columns, this is exactly what you would get. This is a diagram of that. And this is a heck of a lot easier to read. So think about this thing really, really hard in your design phase. Okay, that's something we learned a lot. Now, the string at the bottom here is, I mentioned the part about the pairs can only match in certain ways because it's pretty common within the genetics world to see strands described in this thing because you always know what the top part is. You can write down just the bottom part, GACCG, and you can always infer the top part based on that. That's kind of a handy thing. So I'm mentioning this because our application is going to look like this. We're going to let people enter that shorthand, GACCG, and then we are going to draw a diagram that looks a lot like that. And then somehow this will help clinical geneticists save the world from cancer. Right? So that's what we're going to do. Now, the main thing to remember is it's just like any other app. You know, this is an app that just happens to use SVG instead of HTML in this case. So you don't want to like leak all sorts of drawing information throughout your entire code. So I'm going to start off with just building a backbone model. If you're not too familiar with Backbone, it's not really important here, but this is just a simple model. It has nothing to do with any of this. This top base and bottom base don't even refer to the position. They just refer, that's the technical term, the top and the bottom, okay? And then we have some business logic here about inferring what it is. This is a plain JavaScript object. And when you're using Backbone, then you often create a collection. It's like a repository specific for that object, all right? Don't worry about it too much. The important thing here is that whenever you change something in Backbone, it throws an event you can capture, and that's a really, really handy way to know what you have to change. Now, I'm going to use a little bit of HTML here, and then I'm going to use a view, which is kind of like what we consider a controller in PHP land. And like whenever I click this redraw button, it will fire a reset event on the collection. All right, and that's on the collection, not on the view. It's nicely decoupled. So if you look at this, this is the entirety of what we have. This is our extremely fancy application. I click the redraw button, it's turning that stuff into a list of models, but you can't see anything on the screen yet. Okay, so not too impressive. So I'm going to start off with my rendering layer now. So we got models, we got controllers roughly. I want to talk about rendering. This is a plain JavaScript object. If you like strip away, you're not doing jQuery or anything. This is what a new object in JavaScript looks like using prototypal inheritance. Now I'm going to create sort of a standard render function on here just to give it kind of an interface. And it's going to take the collection and every time you call render. And it has a paper that it's taken in the constructor. So pretty standard dependency setup. Now what I'm going to do is I'm going to wire this into the collection so that anytime I reset that collection, then it's going to fire that event. So every time I click the button, I'm erasing all my models, I'm putting new ones in, and I'm sending an event that this is happening. All right? Now, quick refresher, this is what we want to build. Now, the easiest way to do that, I think personally, just looking at it real quick, is I'm going to draw these sequentially. I've got a list of pairs. Each pair is basically one column. So that's a pair, that's a pair, that's a pair, that's a pair, that's a pair. All right, so I'm going to draw it just like that, going from left to right. Okay, here's how I do this. My render function is going to be obsessed with creating a set on the screen. That's just going to draw several rectangles on the screen for each pair over and over and over again. And it's going to first check, do we already have a set on the screen? If we do, go ahead and remove it. We're drawing from scratch again. If we don't, then let's start creating a new set and we'll do the actual drawing in a draw function here. All right? Now the draw function is just going to loop over the pairs and it's going to defer to a render base function. One for the top one for the bottom one. And it's going to pass in the index and a true or false about if this is the top or the bottom. Just bear with me here. Okay? Now, the actual render base function, this is where the actual drawing takes place. What it's going to do is it's going to pass in these colors. This is just a map of, hey, I want this color. I like a medium sea green for this. And then, or tomato. And then I'm going to draw a rectangle, just like you saw, like a little square on the screen. I'm going to fill it with the correct color, and then I'm going to put the letter in the middle, just like you saw in that example diagram. Okay? Now, I want to calculate where this stuff sits on the screen. All right, so what I'm going to do is I'm going to use the index that you see me pass in. It's going to be a zero-based index, 0, 1, 2, 3, 4, 5. And I'm going to say I want 80 pixels between these things. So it's going to be index times 80. That will give me the x-coordinate. Always plus 10, so I have a little bit of margin from the side of the screen. And it's going to look like that. And for top and bottom, I have to think about that. Yeah, that's readable. This is not so much fun. And the first time that I have to actually go through here and change my padding or my margins, I'm really going to hate myself. And this is just one part of the code. This isn't the whole thing. All right? So let's think about separation of concerns here real quick. I'm building a renderer object. My renderer should render. That is not necessarily the same thing as positioning everything. So if I look at this and I say, okay, what's an easier way to break this sort of thing down? How can I think about this? I could use a grid. I could create a grid of tiles. And these tiles would be much more concerned about the actual placement on the screen. This is how many of our beloved childhood games were created. And all of these wonderful 16-bit games, they use tiles. All right? Now, there is a pixel grid, every individual pixel, but they use larger ones that make more sense for them. So I'm going to create a grid too. And my grid is going to have a get tile function, and it's going to have the bulk of the calculations in there. That's already a little bit easier to read. I could set this up to config or something like that. And it's going to return a little object for every individual tile that has some pre-calculated stuff in there for me, like the x and the y of the upper left. It's going to have the center x and center y already calculated for me. Just something to make this a little bit easier. All right? So when I come back to this, I can specify, hey, I want tile 1, 2, right? So that's 0, 1, well, actually, there is no 2 on the y-axis, but there's just a 1 there. So it's something like that, okay? So that's a little bit easier to read. So let's think about this with our renderer again. Now, the draw function is going to loop over, but instead of passing in like a top or a bottom boolean or something ugly like that, it's going to pass in a tile this time. And we're going to figure out the title for this index, and then 0, 1, so top or a bottom row. All right? And at that point, we change this code from what it was into something like this, which is already a little bit easier to read and a lot easier to maintain because the calculations are all in one place in our code now. Now we still have a couple numbers running around, like the size of our rectangle, right? So I could change this to like have a percentage function. I want this to be 40% of whatever the size of the grid is, rather than defined in absolute stuff. That may or may not be relevant for you. You're not going to get away from some numbers running around in your code, but you don't have to be super mathy about it, nor do you have to smear it across every single object in your application. That will cause you more pain faster than anything. So keep in mind, this grid object I built, that is not framework related. Neither Raphael nor Backbone recommend I do anything like that in here. It's not a best practice. In fact, it's probably not even a great practice. And it's certainly not relevant for every project. If your project does not need a grid, do not build a grid. The lesson I'm trying to impart here is that you should improvise. When you're building this kind of thing, it's not like a back-end application where we've all been doing it for 10 years. Your OOP skills will probably be more important in this stuff than they will be for actually building the back-end server behind it. You will need to improvise and think about what makes sense for your domain model a lot more. And by the way, it's a rendering layer. It's lots of objects probably, and you want to break them up as much as you can. So if we actually look at what we have right now at this point, then if I click the redraw button, then I get a list of boxes on the screen. This is not so very exciting, but it does work, and it works fairly well. And I can change it to something else if I want, you know, shorten it up a little bit here, and I still see my stuff on the screen. So that's our example so far. But you'll notice we're kind of missing something. We don't have any lines in the background. Yeah? That's what we had in our original diagram. So I want my lines. All right, now we're going to do this in almost exactly the same way. I'm going to build a line renderer object instead of a pair renderer object, and my draw function is going to draw an upper line and a lower line, and I'm going to use the grid again in order to get the placement for this stuff. But what I'm doing here is I'm using collection.length for the x parameter, because remember, our grid is 0 based, the length is 1 based, so this will give me the x and y coordinate of the thing that's past our grid. You know, so I can use that instead, which is a nice little piece of code reuse. All right, so 0, 1 for top and bottom, that's it. And this is the entire draw line function. I just draw a path that starts over here and then goes over there. Now, admittedly, the JavaScript string interpolation syntax is, in a word, hideous. So Raphael actually ships with some functions that kind of sprintf, maybe make it a little better. There's another version that uses names instead of numbers, but yeah, whatever floats your boat. All right, so I'm going to change it a little bit by using stroke color. That's the actual color of the line. It breaks it up a little bit, makes it softer and fuzzier, warmer. And then I'm going to use to back. Now, I don't have any guaranteed order about which of my renderers are going to run. You know, I could hook the events up in a particular order, but that's not very helpful. It's kind of brittle, in fact. So the to back function moves whatever I draw here to the very back. It's like, you know, sending it to the background like you do in, you know, PowerPoint or something. So the thing about to back and to front is it's actually a bit of an expensive operation because you're doing several down moves when you do that. So don't overuse the function, but it does work out all right. So if you take a look at what we have now that we have this line renderer in place, I can redraw, ta-da, and now I have my lines. And that's basically our little sample application. It's not real fancy, I know, but it is split out, and it works, for better or for worse. The code is mostly procedural rather than object-oriented. There's a lot of things that could be done. For example, you know, the dual line thing is leaked throughout the entire code. I could maybe make one render just for the top and one for the bottom, for example. That would probably be better. But it's a nice, simple application, and there is room for refactoring. Now, I'm not going to do that. Instead, I just want to point out one last thing about this code sample. You notice that when we created Raphael for the first time, that I'm just going to create a standard drawing size, 300 by 300. If I try and put something on the screen and then move it outside of that, it's not disappearing just because that's where this projector screen ends. There's actually some white space over there, and it just cuts off entirely. It like disappears into thin air. So it won't work. So if you apply that to our actual example, then I don't know how many bases I'm going to be putting on the screen. I don't know how big my drawing area needs to be. So I need to account for that. I need to resize my paper size dynamically. I won't create some big object for that. I'll just show you. You can say when the collection resets, then I will just get the exact width again that I need, and I'll use 2 here for the y-axis. And then I can just say paper.setSize, and that will move it dynamically. And it will always be as big or as small as I need, which is really good because that will make the scroll bars in your browser work. Okay, so general setup, backing away from the code here for a moment. We have a pair render, we have a line render, we have a resizer. These all work on the rendering thing. They all work on the same paper instance, but they are separate objects. They have different behaviors, they work differently, and I could refactor, I could move them, I could tweak them, I could put options on them, and they're separate from each other, which is really cool. Now, a quick watch list of problems you'll encounter. In a mind-boggling omission, the current version of SVG does not have text wrap, the one that is in all browsers. If you put a long string of text in there, it will not wrap to a particular size. It will just become a very long string and shoot off your screen. The mind boggles. All right, so easy, quick workaround. Create an absolutely positioned div on the spot you want, and then put the text in there. That will work. You could use a T-span. This is a well-documented SVG hack, but it does not work in all circumstances, and we could not get it to work for us. Your third option, and the one we resorted to, is roll your own based on bounding box calculations. I do not recommend this idly, or at all. DOM insert order. If you have a view inside a view inside a view inside a view, and the innermost view creates a Raphael instance, this is a really common pattern you'll see with many JavaScript frameworks. And the reason for that is because they don't want to attach the topmost one until all the sub stuff is finished. But if you start drawing when you first instantiate it, and that top part is not in the main body yet, then you will receive many, many strange errors on your screen. So the best thing we found to do was go ahead and create everything when you start loading your backbone views or your Ember templates or whatever you're going to do, and then use a draw event. Just broadcast a global draw event, and then only start drawing to your paper when that happens. Percentages. SVG, again, a mind-boggling omission, partly due to regressions in VML and IE8. Not directly related to each other, I know, but percentages don't work in SVG. You can't say, I want an 80% whatever. You need to use transforms instead, and that's pretty easy with just a scale transform, but it is kind of a weird one. Or you can account for it in your code directly by just using, that percent helper function we added to our grid. Interactive elements. If you have a set of stuff, you want it to be clickable, then use a hotspot element. Do not just bind a click handler to the entire set, because if you do that with a hover and you move over the text to the rectangle, it will flicker badly. That is an IE specific problem. It gets worse in other browsers, and you're binding more handlers than you do. So just create one transparent element, put your click handler on that. Okay, so I'm going to mention some buzzwordy, patterny stuff about what we found worked well for application. If you're not already asleep, this will certainly do the trick, but then it'll be over quick. Okay, so one thing we found worked really, really well here is it's a good practice in JavaScript to use events for binding your application, but this worked doubly well here because you get lots of loose coupling between your rendering layer and the rest of your application. So I can create an event dispatcher with Backbone really easily, but there's probably one available in whatever your local framework is if you need it. And then you can do something like, hey, in my rendering layer, I click something, I don't do any model changes directly in the rendering layer, I just fire an event. All right? And then somewhere else in my code, I can listen for that event and copy it to the user's clipboard. Or I could display it on a palette. This is a nice way to couple this stuff really loosely, and it works really, really well. We also found that the command pattern worked well when our application got very, very big. I'm not entirely sure why command seems to work so well with this, but it basically relies around the fact, if you haven't seen the original one, of taking warehouse.resupply and changing it into something a little bit bigger like this, where it's more like a data structure I'm passing through, and then there's a central processor that just listens for that kind of event and then changes it. I'm glossing over it, but that's the general thing. This worked really, really well for a number of reasons. We have sequence. JavaScript is single-threaded, but we could ensure if we collect many events that we can do them based on a timestamp, for example. We could have interceptors so that we could run everything through a validator. We could have debugging logs, and this is a big one. If you're implementing lots and lots of different custom widgets or clicks or something that your user does to build up an event or a model change, this will tell you every single thing that they did to bring up to that point, okay? You will get a debug log that says they clicked here, then they clicked here, then they clicked here, and then this happened. That is really helpful. You can have higher level events based on these if you prefer to do it more domain-oriented instead. That's pretty cool too, actually. You can also do some crazier stuff like multi-user editing, taking in lots of commands from lots of users over WebSockets. Or you can do undo operations, like Control-Z backwards in your command list. That's kind of the canonical example of why you would implement the command pattern. I would recommend this for mid to large stuff. If you're just building like a US map or something like that with different changing colors based on voter demographics, that's just kind of a simple visualization. Command pattern is way overkill. All right, decide based on the features you need to implement. If you're going to build undo at some point in the future, do yourself a favor and start with it now. Now, commands plus promises, I won't talk about what promises are. Anthony Ferreira is running around, so go bug him. But promises are really, really cool because you can create a promise for every command. If it's asynchronous, then you just wait for the promise to be done, and you can replace inside there. The cool thing about promises in this context is that they are values. So you can pass them without breaking your architecture too much. I could start off with the promise down in the rendering layer, I could do one in the model layer, come up all the way down to my rendering layer again, and I'm not creating any kind of like really hacky, ugly thing. It's just a nice, clean value I'm passing around. And the final topic real quick to talk about is testing. Testing is really hard, actually, because with models, commands, controllers, this is stuff people have all tested before. But for rendering, it's a little bit trickier, because it's mostly about, I can query the DOM for like the X coordinate of something, but then I'm just comparing it to a big list, and it's brittle, and it's not a very good test, actually. So you'll often find yourself just eyeballing this. So I can't overstate the importance of building good fixtures enough. If you are relying on sort of manual user testing, then you could use Phantom.js and give yourself a break here. Now, Phantom.js will let you just create a PDF off of a current page. So I created this PDF right here based on an example from the raw file page. It works well, and I could say generate 30 PDFs really, really fast, and then just check them by hand quicker than I could click through the browser. It's not a comprehensive testing solution, but I don't have a better one at this point, I'm afraid. So this is where we part ways, unfortunately. Is this the one true path? No. It is pretty clear from what you've seen over the last however many minutes that I do not know that much about graphics programming. All right, fine. But nonetheless, this is a surprisingly walkable path. I think pretty much anyone can slap together an application that uses something like this or a simple data visualization. The best advice I can give you is build a proof of concept. You can think about this and read about this for 2 weeks, and you will still make more progress in 2 days by just trying to get the effects you want on the screen. Throw it away at the end, build the abstractions you need to clean the code up, but just build the proof of concept. I'd be much happier you did. Now, finally, wow, insert inspiring story here. When we were actually building this application, we were delivering weekly to the client. We worked really, really closely with them. There came a point in the application where the user came over for his weekly meeting, and he said, yeah, I want to talk to you guys about printing these diagrams, like out on paper. We're like, yeah, that's not in the spec. And he reached into his backpack, and we got really afraid. And he pulled out this giant stack of paper, and he like spread it out over the thing, and it was one of our process diagrams from the current development version. And he'd printed it out on paper, and he'd like blown it way, way up, and it was vector graphics, right? So it scales, and it looked beautiful. We were using Bootstrap, so it just hid the menu and everything like that, and it looked beautiful on paper. And we were like, wow, we did that. Thank you very much for coming. I know it was trying. All right, so, yeah, whatever. I used a lot of people's images. Thank you for their time. And thanks again to these guys. I'm pretty new to this conference speaking thing, so reviews, comments, feedback, please put them on joined in. If you like what you saw for some reason, then that'll help me go into the next conference. Otherwise, I'll try and work on it. Thank you very much for your time.
Curious about the interaction with CSS and the SVG elements. Could you say a little bit about CSS and SVG elements? It seems like you are going back to the old school way of HTML, where you say width equals 50 and color equals red.
You heard the question. It's pretty interesting because some of the stuff you can actually do with CSS styles. You can actually put a class on a rect element and put your width and your fill and stuff there. They're named a little bit differently, but it does work. But not everything seems to work across the board. So my advice is to probably just still draw it manually for each element you do. One of my colleagues is a big fan of creating a config, where you just have these objects, and then you can pass them all into the attribute function, like when you're drawing that. So you might have, hey, for X widget on the screen, here's the attribute config, and then that just gets passed in. And that actually works surprisingly well if you keep your config up to date. And it's also a good place, by the way, too, to specify width, height, and so on and so forth. Yeah. Any other questions? Yes, sir.
I heard you very briefly mention Ember.js, just offhandedly. I was wondering if you guys sort of debated about what front-end MVC framework to start with before building your app.
Yeah, it's a good question. I think in theory you can use anything here because it's really about decoupling the rendering layer. That's the main message. We used Backbone in this case because that was one of the few front-end frameworks we had a little bit of experience with. We were pretty pleased with it, and we were also really, really concerned about the performance issues. So we felt like by using Backbone and like stripping it down to sort of the core that we might have a better control and might have better control over that. So that's kind of how the discussion went. I will say that in the end, we combined a lot of HTML form elements and stuff rather than making everything through SVG. I highly recommend doing that. And we also used Backbone.Marionette. That was still a little bit new then, but we actually turned out to be really, really phenomenally pleased with it. But Ember.js personally I haven't worked with, so I couldn't debate the merits of that versus something else. I do think that there's actually room, by the way, for maybe a cool Raphael Angular hybrid, but I have not yet tried. Anything else? Well, thank you for your time and your patience. Have a great evening.